Today we're going to be talking about trigonometry. So trigonometry was the study of right triangles. We looked specifically at right triangles and right triangles only, and we looked for some patterns. So if I have a right triangle, this time it can be any right triangle. It doesn't have to have specific angles inside. We're not working with our special right triangles at the moment. If we have any right triangle, we need to be able to name the sides. Well, we know the sides relate to an angle. So inside, and it never relates to the right angle, it's going to relate to one of the other angles. So I'm going to give this angle a name. Now commonly in mathematics, when we give an angle a name, we use that symbol that I've drawn in there, a circle with a line through it. This is the Greek letter theta. And it's commonly used to represent an angle we don't know. So I'm going to call that angle theta. And I'm going to name all of the sides in relation to that angle. So let's say I take the side across from theta. This side is normally called opposite because it's on the opposite side of theta. And usually we just write OPP for opposite because we're lazy and we don't want to write the whole word. Well, then we look at the other two sides. The bottom side is next to theta, but so is that slanted top side. It's next to theta. Well, that means they're both close to theta. We can't just call them both sides that are next to theta. They have to be different somehow. So next we look at actually the right angle. We know the side across from the right angle is always called the hypotenuse. Again, we're just going to use HYP for hypotenuse. So that side is always the hypotenuse, so that makes it more special than the other side. So the other side we can say, well, that's next to theta. Obviously next to is not mathematically nice enough, so they call the side next to adjacent. But again, normally we just write the ADJ to mean adjacent. So in trigonometry, they wanted to compare all the different sides to each other. They wanted to say, what's going to happen if I divide the opposite over the hypotenuse? What's going to happen if I divide the opposite over adjacent? And they found that when you do that, it gets the same answer every time if your angles are the same every time. So they came up with three trigonometric functions: the sine function, the cosine function, and the tangent function. So the sine of that angle, theta, and they could have called it anything. We could have called it the bob of theta, but obviously they use more Greek and Latin terms because this is when a lot of these terms were coming about. Sine of theta is opposite over hypotenuse. The second trig function they found was called cosine. Usually we just write COS for cosine. So cosine theta is adjacent over hypotenuse. And our last one is tangent. Which is opposite over adjacent. Now these are formulas you will need to have memorized eventually. So usually the way we remember it is by using the first letter in each of these. So sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. Putting all those together, we get so, pa, toa. That's the most common thing you'll hear when people are trying to remember their trig functions, is they'll say SOHCAHTOA. Kind of sounds like soak a toe or something like that. But SOHCAHTOA means sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. It's a way for us to remember that. So let's say we take a right triangle. Now notice I did rotate it around. It doesn't have to be in the same order that we worked with our original triangle with. And I want to find the sine, cosine, and tangent of this particular angle, theta. I even moved where I put theta. So we've got to go through and first identify the opposite, adjacent, and hypotenuse. I actually usually start with hypotenuse when I'm thinking this through. We know hypotenuse is across from the right angle. So 13 would be my hypotenuse. Then we look at the angle that was given to us, theta. Opposite of theta is the one across from theta. So 5 is opposite, and 8 would be left to be adjacent. So now we know which one's opposite, which one's adjacent, which one's hypotenuse. Now we just plug them into the trig formulas. So we know sine of an angle is opposite over hypotenuse. Well, we've labeled which is which. We've labeled 5 as opposite, 13 as hypotenuse. So we would plug in the numbers. 5 is opposite over 13, which is hypotenuse. So the sine of theta is 5 over 13. If I could reduce, I would, but 5 over 13 doesn't reduce. Cosine would be adjacent over hypotenuse. So 8 was adjacent, 13 was hypotenuse. Cosine of that angle would be 8 over 13. And tangent would be opposite over adjacent. Again, if it could reduce, we would, but none of those reduce. So we found our 3 trig functions for this particular triangle. Sine is 5 over 13, cosine is 8 over 13, and tangent is 5 over 8. So I want you guys to actually try one on your own. I'm not going to tell you the answers, but I am going to check in your notes tomorrow that you've tried this problem. Again, I want you to find sine, cosine, and tangent. And that's the triangle I want you to try.